This is 12.1 Polynomials. This is the last chapter we will be covering for the end of school. This is one of the most important chapters you will see in this entire pre-algebra curriculum as far as getting you ready for algebra. What we want to look at today is what a polynomial is and just some basics of polynomials. I'm not going to get in too deep today, just basically touching on the basics. Okay, a polynomial is a sum of monomials. Now, if we remember from chapter 4, we remember that a monomial is, we had a GCF and LCM of monomials, so it's basically a constant or a variable or a collection of constant and variables multiplied together, okay? And so if we look at these, this by itself is a monomial, okay? This by itself is a monomial. This by itself is a monomial. But when I put an addition and subtraction sign between them, this becomes a polynomial. Well, monomial is a polynomial anyway, but there's more than one term. So monomial just speaks of something with one term, okay? But if I add those together, I get more than a monomial. I get a polynomial, okay? So each monomial, each in a polynomial is called a term. So this is a term, this is a term, and this is a term, okay? Again, terms are separated by addition or subtraction signs. Polynomials, some can be classified by the number of terms. So a more specific name for a one-term polynomial is, as we said, a monomial. A more specific name for a two-term polynomial, like I have here, that's two terms, would be a binomial. Bi is two. Three terms, like I have here, would be a trinomial. Now there are names for things more than, for polynomials with more than three terms, but we don't need to know those. I don't even know those right now. I'd have to look them up. Nobody ever uses them, but we do use monomial, binomial, and trinomial. So we're sticking with those today. Let's look at the next one. Now we're going to tell whether the polynomial here, or the expression, is a polynomial, then list its terms and classify it. So for an expression to be a polynomial, all variables must have non-negative exponents. In other words, a variable cannot be in the denominator. So I could not have, for instance, 1 over x. That's a no-no. It wouldn't be a polynomial if I had 1 over x. Okay? If I have a negative exponent, that's the same as having a variable in the denominator. If I go at x to the negative 2, remember to make that positive, we move it to the bottom. So that would be the same as having a variable in the denominator. So let's look at this first one. I've got positive exponents, so I'm good. This is a polynomial. What are its terms? Well, the first term is 6x4. The second term is negative 5x3, and that's how you'd list it for your homework. And then I classify this polynomial, because it has two terms, it would be a binomial. Okay? I'm just going to go across here. This is one term. It's one term because there's no addition or subtraction signs in there. It's all multiplied together. It's one term. So if I was going to list this, I would have to just copy this one term down. And more specifically, this is called a monomial. Okay? Here, this has a negative exponent. I can't have that in a polynomial, so we would just write no, this is not a polynomial. Okay, here, this has a negative exponent, so we would write no. Now, I can have negative numbers, just not negative exponents, okay? This is not a polynomial. Well, this is, I don't have any problems with exponents here, and the three terms here are 3a, 7ab squared, and 2. And we would call this a trinomial because it has three terms. Here I've got no negative exponents, so my three terms are 3x squared. I'm sorry, I put a cube there. 8ab and then negative 1. That is called a trinomial. There are three terms. Okay? Next section. The degree of a term is the sum of the exponents of its variables. So when we're talking about degrees here, we're not talking about like a measurement of an angle. The degree of the term is defined differently. It's just the sum of the exponents of its variables. The degree of a polynomial is the greatest degree of its terms. Okay? Any degree of a non-zero constant is 0. The constant 0 has no degree. Okay, so let's look at this one. This first term, look at the exponents. This first term has a degree of 4. The second term Let's kind of do something in a different color. Let's see what this looks like. This first term has a degree of 4. The second term does have an exponent. It's 1. This has a degree of 1. This has a degree of 0. So the degree of the whole polynomial is the largest degree. That would be 4. And that's it. There's no real work here to do. You're just looking at each term. This term has a degree of 4. This term has a degree of 3. Looking at the exponents. It doesn't matter about the negative. I'm not concerned about that. I'm just looking at exponents. So the degree of the whole polynomial is 4. Look at number 2. This term, it's a constant, has a degree of 0. This term has a degree of 3. The exponent is 3. This term, I have an exponent here of 1, has a degree of 1. The degree of the polynomial is 3, the highest one. Okay, this term has a degree of, well, here's a 1 and here's a 1. 1 plus 1 is 2. You have to add the exponents in a term. Within the term, you add all the exponents. No matter how many exponents you have, you add them together. Okay, just on the variables. Because technically I have a 1 on that 7, but we don't mess with that. We're just dealing with exponents on variables. This one has a degree of 7. 3 plus 4 is 7. This one has a degree of 3, so the degree of the polynomial is 7. This one has a degree of 4. This one has a degree of 5. This one has a degree of 0. So the degree of the polynomial is 5. Got to put the little, there we go. Okay, this first term, there's a 1 on that m. 1 plus 3 is 4. That has a degree of 4. This has a degree of 4. So the degree of the polynomial is 4. Okay, and that is simply degrees of polynomials. No degree sign because we're not dealing with measurement of angles. Next, a polynomial is written in standard form if it is simplified and the terms are arranged so the degree of each term decreases or stays the same from left to right. So we're going to write it in standard form, meaning the highest degree term goes first, the next highest degree term goes second, and so on. So we got 3 terms here. This has a degree of 2, this one has a degree of 1, and this one has a degree of 0. So to write it in standard form, I simply rearrange it like this, so that the degrees are going down as we go left to right. This has the highest, this has the next highest, this has the lowest. That's it. Okay. Now this one I have to simplify. So remember, we have to multiply this through the parentheses. I get 4a minus 5a cubed minus 5a minus 3. Okay, now I'm going to have to combine like terms here. I've got a 4a and a negative 5a. But I'm going to I don't have a lot of room, so I'm skipping a step here, but just stick with me. This has the highest degree, negative 5a3, right? Yes. Okay, the next one's going to be this one. It has a degree of 1, but I'm going to go ahead and subtract them. 4a minus 5a is 1a, negative 1a. So it's just going to be negative 1a, and that's next. Then the last thing is the constant, has a degree of 0, negative 3. That's in standard form. Okay, look at this. Add the like terms together, 7x3 and 1x3. That is 8x3. Remember, we don't add exponents when we're combining like terms. That's only when we multiply. Adding exponents only when we multiply. 7x3 plus x3 is 8x3, and that's first because it's the highest degree. 2 minus 5 is negative 3. Okay, this has a degree of 3, this has a degree of 0. It is in order. We're good. Next, get rid of the parentheses. 12b plus 3b squared minus b squared. Okay, I know the b squared is going to be a higher degree than this, so it's going to have to go first, but I'm going to combine them and then write it. 3b squared minus 1b squared is just simply 2b squared. Okay, and then put the 12 next because it is the second or the last. Okay, this has a degree of 2, this has a degree of 1. Next, the only combining I have to do are this and this, but this one's going to have the highest degree. It has an exponent of 4. So this is 8y4, and that's going to be plus 8y2. Okay, and that's done. Here, multiply. I get y squared plus 8y3 minus 2y plus 10. Okay, rearrange. This has the highest degree, 8y3. Next is the y squared. Next is the y. Last is the constant. Okay, last but not least, I don't know if this color will work. Yeah, it'll work here. Let's simplify. Let's evaluate. So we're going to substitute and then evaluate. So I'm just going to put in 3 for x here, and this is how you show it on paper. You'll substitute, show the substitution. Put 3 for x here. Now I just need to evaluate. 3 squared is 9, minus 4 times 3 was 12, plus 4. 9 minus 12 is negative 3, plus 4 is positive 1. There we go. Again, simplify, substitute, simplify. You've done this before. Negative 2 squared plus 5 times negative 2 minus 1. Remember, when I square a negative, I get a positive number. So that's going to be positive 4 times 3 is 12. Minus 10 minus 1. Again, 12 minus 11 is 1. Okay. Here, x is 3, y is negative 2. I get 3 minus 6, or 3 plus negative 6. That's going to be negative 3. Here, xy, 3, negative 2, minus 7 times 3, minus 2. This is negative 6. This is negative 21. This is negative 2. 21, 23, that's going to be negative 29. And we're done with that. Next one, I have 2x squared. So I'm going to substitute 3 for x. That's going to be 3 squared. Negative 2 for y, plus 1. 3 squared is 9. 9 times negative 2 is negative 18. Negative 2 cubed is negative 8. You've got 3 negatives you're multiplying together. You get a negative answer. For when I cube a negative, I get a negative. So it's negative 8 plus 1. So this is negative 26 plus 1 is negative 25. Okay? Substitute 3 squared, negative 2 squared, plus 3 times negative 2. 3 squared is 9. Negative 2 squared is positive 4. And that's going to be minus 6. That's going to be 36 minus 6, which is equal to 30. Okay? Again, substitute, show the substitution on your paper, then give me the answer, the evaluation. Okay? That sums it up for our introduction to polynomials today.